All right, so the last time we met, there were a couple of students that have Java 1, but they had a different language, right? So they didn't actually have Java. So, I mean, I know I said I was going to review, so I decided that I'm just going to, like, maybe take 2 weeks to review. I'm going to just start from chapter 2, but, like, I'm going to breeze through everything. I'm just going to kind of go over everything. It's up to you to take the time out to learn Java if you don't actually know Java. But I'm hoping to cover chapter 2 and 3 today, and then like next class, maybe chapter 4, and maybe go more in chapter 4 on the following Monday, and then finish off with 5 and 6. Yeah, so I'm gonna go ahead and just open the lectures, just kind of go through them really quick. And if you have questions, you can stop me, but a lot of this might be like really dry for those who already know Java. Okay, so in chapter 2, we talked about character strings, we talked about variables and assignments, primitive data types, expressions, data conversions, and interactive programs. Okay, so I'm going to kind of breeze through all this and then like do an example toward the end. All right, so character strings in Java, in most programming languages, you have what they call strings, which is just a group of characters. So in Python, it exists, right? It also exists in C++. So it's the same thing in Java. Anything surrounded by a double quote is considered to be a string literal. Okay, so a string is an object in Java. What an object actually is, it's a, what do you call it? It's a data type that's not defined by a size, right? So primitive data types, we're talking about that. There's 8. We have 4 for integers. We have 2 for floating point values, and we have a Boolean and a character. Okay, those all have a predefined size, where an object is just like data inside of memory, where the variable actually points to where it exists in memory and doesn't really know any information about the size of how much room it's taking in memory. Okay, so that is a string. There's like methods like system.println to write stuff to the console. Yeah. And then there's some character sequences. Every programming languages have them. Well, you can like type, excuse me, do new lines, do tabs, do double backslash to print out a backslash inside of a string. Let's see, where's primitive data types? Oh, constants. All right, so I do have coding standards. I don't know if you guys have seen that. Let me just hop over to coding standards really quick. So under discussions, if you click on coding standard, now the coding standard is just how we need to format our code for me to find it acceptable. So for class and file names, we are always going to use uppercase to name our classes. Excuse me. But our class name should always be meaningful. Meaning, if you're writing a program that prints a diamond, it's named diamond, or a tree, Christmas tree. But it shouldn't be things like quiz 2, programming 1.9, right? It should have meaning. Variable names should all be lowercase, but camel case for you have a second word. So first name where the N is capital, and then method names, same thing, lowercase. Constants, all caps, okay? There's no camel casing, right, because it's all caps. So we use an underscore to cause that visual separation between words. Variable declaration should be at the top of the method or top of the class. So here is where all your variable declarations are done. It makes it easier to just see what type of data you're using inside of your program. All right, and then whenever possible, it's always preferred to use a math class to do things like taking something to the power of 2 or things like that, square root, right? So just keep that in mind. All right, that's constants. I mean, in Java, we put the final modifier in front of it. So a constant, does it even show you an example? Yes, it does. You use this final modifier, and once you give a value to that variable, it can never be changed. If you try to change the value, the program won't even compile. Okay, that's the way we declare constants in Java. Primitive data types, there's 8 primitive data types. There's, excuse me, 4 for integers, byte, short, int, long. You have 2 for floating points, float and double, 1 for char, 1 for Boolean. Here are the data types. I don't really expect you guys to know the min and the max values, but I do expect you to know the storage size, right? So a byte is 8 bits, short is 16, int is 32, long is 64, float 32, double 64. All right, then we talk about characters. In Java, we get our characters from what we call the Unicode character set. So characters actually have numbers that represents an entry in the Unicode character set. There's up to 65,000 unique characters. The first 128 are from the ASCII character set. And yeah, you can read more about that. I don't really know if I'm going to talk much about that, but that's something you should already know. Here, Boolean types. Every programming language has a Boolean type where it's either true or false. In Java, you cannot use ones and zeros. I know in other programming languages you can use ones and zeros, but Java, you cannot. Okay, and the reason behind that is that Java actually defines true or false. I read about it somehow, but it doesn't actually represent true and false with ones and zeros. Okay, expressions. Right, we have all the same expressions: addition, subtraction, multiplication, division. That's and remainder. That's normally pretty consistent amongst programming languages, at least the ones that I've used. It's never changed. Right, you want to add something, you use addition, right? The plus, subtraction, multiplication, division. I'm trying to think if everybody uses the remainder the same way, right? Or the modulus. I don't know. I believe so. And they kind of give you some examples. I'm not going to go through all that. I mean, primitive data types, pretty simple. Pretty standard across most programming languages, except for Python, where there's data types, but they're not strongly typed, so a variable can hold anything, which can be kind of confusing. All right, in Java, okay, this is actually something kind of important to understand. Okay, I'm probably going to have to do an example because I don't know who understands this and who doesn't. I'm going to do a quick example about the different data types and converting one to the other. So I'm going to go ahead and just open like a quick program. So I'm just going to open Notepad++. And I'm going to create a new file. All right, let me save this to Dropbox. Big folder called Simple Demos. So this is where I'm going to put Java programs that obviously use Notepad++ for, and the ones that are I'm going to use IntelliJ for is going to be in the IntelliJ workspace. Okay. Wait, man, that sucks. I made a folder right out of. This should be like in its own folder. Dang, messed that up. All right. Anyways, I'm going to call this one. I don't know, data type example. All right, so in Java you have 8 primitive data types. You have byte, which can hold up to 2 to the 8th power, which is 128, or no, not 128, 256, right? So it's, the lowest value is like 120 or negative 128. Highest value is 127. So I can make a byte. Let's call this one now 1, and we'll just say it's equal to 7. All right, and we'll have a short. Now 2, and it's a little bigger because it uses 32 bits. So 32 bits can go up to, I don't even know. Anybody know? A million something? I don't know.
4 gigs.
For what?
4 million.
4 million? All right, something like that. So we can go bigger than a byte. So we can just say it's bigger than a byte would be like 200, right? And then a int, which is, int is 64, short is 16. Dang it, I messed it up. All right, so int is, that can be up to 2 billion, I think, right? I don't know. Sorry, I don't have all this memorized. I've been programming for all these years. I don't memorize like the size of these variables. I just know like you can have something like that and be okay. Okay, and let's see, the next one is long. Okay, so this one can go up to 64 bits, and 64 bits can be really, really long. I think like 14 digits, right? So oh, that's 3, 4, 5, 6, 7, 8, 9, 10. We'll say 10. Okay, and I don't think Java's not going to like that when I compile. Actually, let me save this really quick, and I'll show you why Java doesn't like it. I think it's not going to like it. I don't know. I mean, normally, in all my experiences, it won't like it. So, change directory to Dropbox, public, NVC, Spring 2020. Dude, simple demos. God dang it, what the heck. Simple, wait. Oh, duh. All right. All right, so I'm going to compile the one file that I have in here, which is that. All right, so Java's upset, okay? The reason why Java's upset is because whenever Java sees, like this is something that's different amongst different programming languages, Java's gonna see this number, okay? Now, whenever Java sees any number, it's gonna treat it like an integer, okay? Except for some reason, I don't know, by magic or whatever, if it's small enough to fit into a short, it's going to auto make this a short. If it's small enough to fit into a byte, it's going to auto make it a byte. So this is okay, this is okay, this is okay, but this isn't okay, right? This is too big for an integer. It's big enough to be long, for assigning it to a long, but Java's like complaining, right? And its complaint is that the integer is too large, okay? Now, whenever we have a number that's too large for an integer, we have to tell Java that we want it to be a long by doing an L. Now, everybody always tells you never use a lowercase L because it looks like a 1, right? To me, it looks exactly like a 1. So always use an uppercase L. Either one would work, right? If I use a lowercase L, save it, come over here, compile. Java sees it as an L, it doesn't see it as a 1, but a programmer might think that's just a 1, right? That's why whenever you're using a long literal, it's always best to use a capital L, and then you come over here and you get the same results. All right, now the way Java works when converting data, right, it sees, without the L, it sees it as an integer. And it's saying like, that's too big to be an integer. It got mad, right? Now, whenever it's too small, like it's going to a short, it will auto cast this to be a short as long as it falls in with the range of what a short is. Auto cast this to be a byte as long as it falls in with the range of what a byte is, right? So if I make this byte bigger than what it can hold, the max value for a byte is 127. So 127 will be okay. If I come over here and compile, Java's fine. But if I make this 128, is when it's going to start getting upset at me. And now it's upset, okay? So that's like the whole data stuff that's kind of important to understand. There's a lot more to this as well. If I wanted to force this to be a byte, I could just come over here and just say, you know what? I don't care what you say, Java. I want 128 to be fit into a byte. Then when I come over here to compile, Java's going to be okay with it. Okay. Now, what's interesting is what value do you think is stored in num1? Anybody know?
Negative.
Negative what?
Negative.
Yeah, negative 128.
127. Oh, 128 negative.
Yeah, because that's the lowest value for a byte. So if I were to print out num1, it's going to be negative 128, right? So wait, I compiled, I didn't run. Dang it. All right, so now I need to run. All right, negative 128. It's right there. All right, so what's interesting is that Java does like that whole flipping thing. I don't know what other programming languages do that. I don't really play with them. The only time I really play with programming languages is in class because students ask questions. Like, what happens to this? What happens to that? And then I'm like, I'm curious too. And then I do it, right? But normally I try, like, I don't just sit around and like, oh, I wonder what happens if I do this on different programming languages. But I know for sure, at least when I was learning C++, is if you did not initialize a primitive data type, it would have garbage in it, right? In Java, it gets upset at you if you don't initialize it, but there's instances to where you can not set it, and it's just going to give it a 0. It gives all integers a 0, all floating point values a 0.0, it gives Boolean values a false, and I don't know what it does for char. That's interesting. It'd be interesting to find out. All right, so I don't know if I should take time to find out, but let's just try it real quick. All right, so I'm going to make another class called my test class, just to test this one thing. All right, and it's going to save it as a Java file. Dang it, I overwrote it. All right, let me open. Yeah. All right, and I have them both up, and they're both named the exact same thing. All right, so I'm making a class which is going to be a blueprint for an object. So I'm going to say private char my char. Okay, I'm not going to set it, and then I'm just going to have a getter. That's it. Public char get my char. All right, so I'm going to come over here. Now the reason we have to do this is like if I do something like this here, if I come over here and say char one, and I don't initialize it to anything, Java's smart enough to complain when I try to compile this. All right, it's gonna come over here. If I say char is, and then try to concatenate in the char, right? Java's smart enough to know like, hey, you didn't initialize this variable. What are you trying to do, right? Because it's all in the same class. So if I come over here, come over here, compile. It doesn't compile. Right, it tells me the char1 might not have been initialized. Okay, but if I put it into a class by itself, make it like instance data, instantiate an object of this class, and then call get my char without setting it, Java is confused. It doesn't actually know you didn't initialize it, so you're able to actually print it out. So over here, I'm going to say my test class. I'm going to just call this one my object, right? And I'm going to say new my test class, right? Instantiated object of this class. Okay, so it's been put in memory. It has its own variable for char. Now I want to see what char is, what's stored in char. I'm going to say get my char, and I think that's what I named that method. That is what I named that method. So save. Come over here. Let me clear my screen. Wait, I'm going to compile and. Oh, I didn't read public. Oh, I put, dang it. Nobody said anything to me, and I did that. What the heck? Who took my Java 1 class? I didn't even, I just wrote like a method with no body. That's what happened. I'm sorry if you were confused by that. All right, so I wrote my method. I have to have a body where I actually return my char, and I'm going to come over here, make sure I'm using everything correctly, compile. It compiles. And then I'm going to run. So it looks like it's the I was thinking it's going to be the very first char inside of the Unicode character set. I don't know what that is because I don't have it all memorized, but maybe it's a space. The one other way we can find out what the very first char is in the Unicode character set is that we can do something like this. First char, and I'll just do that. Okay, now you can convert an integer to a char, and I don't know if this is going to work, but let's try it out. It's the first time doing this. Char, and it's putting like the number 1, right? Yeah, or is 1 the very first one, or is 0 the first one? 0, right? 0 would be the very first one. All right, so let's see if that works. Huh, worked. That's crazy. Okay, so it looks like it is just like a blank space, right? So like if you don't initialize a char, it's going to give you the very first character at index 0, which is space. I think it's a space. I don't know. Sometimes there's characters that are nothing, like I don't know, like a void or just as noise or something like that. I would have to look it up, but I don't have it all memorized because I don't use it that often. Okay. Any questions on this so far? All right. The other thing too is whenever we're going from a higher data type to a lower data type, we have to do what we call casting, and casting is done by using the parentheses and the name of the data type that you want to convert from, right? So, or convert to. So, for instance, a perfect example of this is Oh, here, you know, another thing, another example of this whole float thing, or not float thing, but the long problem that we had is a float, which is kind of annoying. We'll just say num5 is a float, and let's just say a float is a value that can hold decimal points. Let's say I want num5 to be 1.5. Okay, I'm gonna save it here, and I want to print it out. All right, so I'm gonna come over here and I'll just say num5. All right, but when I go to compile, it's not gonna compile. It's the same problem that we had with our long. Okay, now this is the complete opposite, where instead of going, like trying to go higher, it's actually, we're trying to go lower. So what's happening is, Java sees this as a double. A double, like every time you put a decimal point, it sees it as a double literal. A double is 64 bits, where a float is 32 bits. So Java's saying like, hey, if you really want to make this a float, you're gonna lose precision, right? Because this variable here is being stored as 64 bits, and you're wanting me to put it into something that stores 32 bits, right? It's just kind of giving me that hint, right? So you have two options. The worst option is by just casting that to a float. That will work. And you just compile, run, right? It works, right? The more appropriate option is to put an F at the end of it. Lowercase f or uppercase f, it doesn't matter. Both of them are distinguishable, not like the lowercase l, which kind of look like a 1, right? But that's the more accepted enter. Whenever you're making a float literal, you just use the little f there. And now Java will treat that as a 32-bit number. And when you go to compile, everything is fine. Okay. All right, so those are data types. Right, there's all these little nuances that are involved with them. Students kind of run into them in Java 1. Yeah, I don't really know how C++ handles all this. I don't think you have to initialize. Like if you don't initialize a variable in C++, if I remember correctly, it won't actually give you an error when you compile and run. It's just going to give you like a result. And I don't believe it's 0. I think it's just like garbage or something like that, just some random number. Yeah. All right. Any questions on that? Okay, so let's hop back over here. Interactive programs. Okay, so all right, that's it for chapter 2. I'm going to go and just show you how to do interactive programs in Java. If you haven't had Java before, this is how we're going to grab. Excuse me. Dang it, I got my cough. This is how we're going to grab data from the user. Okay, so I'm gonna go over here. I'm gonna say new file, save as. I'm gonna say interactive program. This is a Java file. All right, so in Java, we have this class called scanner. And that's how we scan input from the user. All right, so I'm gonna come up here, and so we have different, so Java, you have different packages where different classes live. The java.language package is always imported, so that's the string class and the system out, or the system class. They're all part of java.lang. So is the math class, right? So if I wanted to use like a math class, I don't need to import anything. I could just come over here and just say like system out print line 5 to the second power. Right, and I just say like math.pow and run out of space. I don't know why I just made that, just pull that out. There you go. I'll just take 5 to the second power. I didn't have to import to use the math class. It's part of the java.language package, so it's automatically imported. So I come over here to compile. Wait, that's the wrong command. it compiles, then to run. Right, I get the result of 5 to the second power. All right, but there are some classes that live in different packages. If we want to use them, we have to import them. So up top, we have import statements. You have to know what package the class that we want to use lives in. The scanner class lives in the util package, so java.util. If you want to use a scanner class, you have to make an instance of that object. So say scanner, scan is equal to new scanner. And then you pass in the object system in, which is the keyboard. You can pass in other things. You don't actually have to listen to the keyboard. You can pass in a string, parse up a string. You can actually pass in a file, read a file. Actually, we're going to do reading files at some point. Okay, so created my scanner object. I just say like I have a variable for somebody's name, and I have a variable for somebody's age, and then I want to ask another question that involves a string. Wait, why did I put a string for age? What the heck? This should be an int. All right, another question that involves a string, so maybe like your college. Right. All right, so I'm going to prompt the user. Okay. So once prompt them to enter their name, I'll prompt them to enter their age and college. All right, so I'm gonna prompt them, and then I'm gonna wait for them to enter something. The scanner is listening to the keyboard, so whenever I get that data, I'm gonna store that data into name, and I'm gonna get that data by saying scan.next line. Okay, that gives me the entire line that they entered. Over here, if I want to enter the age, I'm going to say scan.next int. I'm expecting to give me an integer for the age. I'll put some space here to make it look a little nice. And then for their college, I will say college is scan.next line. All right. And then from here, what I'm going to do is just like output what they entered. All right, dang. Okay, so I'm gonna use the string.format class. I don't know if you guys are familiar with that, but it makes life a lot easier when you're trying to like lay things out. That is something that you should probably like look up because it's very, very useful. So the way it works is I can just do something like this. I can say like name, and then do %s where I want the name to be injected, and then age, do a %d, I believe, where I want the d to, or the integer to be injected. I know other programming languages have something like this. Percent?
It's D.
D, okay. And then college. And I'll use %s for the string. And then inside the format method, it takes what we call a variable length parameters. We'll talk about variable length parameters. Actually, I don't know what chapter, but it is part of Java 2. So I can pass in the name, the age, and the college. All right, save that. Come over here to compile. Oops, that's the wrong thing. Compile. It compiles, and then run name. What the heck? And then like I hit my age, and then I press entered, and then like it didn't let me enter the college. Okay, so this is a common problem in Java. It's kind of annoying. Does anybody know what happened? Anybody remember? I know I explained my Java 1 students like why I hate this.
Scanner line didn't empty out.
Right, so the way the scanning works is by tokens, right? So by tokens meaning like it's gonna look for what we call a delimiter. So we ask for a line, right? So we got the entire line. Then we asked for an age, but we used a token scan, meaning we only took the integer off of that. We left the new line character behind, right? So next time we did like a next line, we grab that line with nothing on it, okay? It's a common problem a lot of students run into. I try to talk about it in Java 1 like right away. It's just something you need to be aware of because you can spend like hours trying to figure that out. Like if you don't know what's actually happening, right? So grab the full line, grab a token off that line, left the new line character behind, and then we asked for the next line, which it thought it was an empty line, right? So the way to avoid this, there's several things that you can do, right? One, like most students are like, oh, I'm just gonna rearrange it to where I do all my token scans last, right? You can ask for the age last, or you can just, what I recommend is just like, if you know you're going from a token scan to a line scan, you could just say scan dot next line. Like just call it and don't capture it, and you kind of get rid of it, right? You just kind of clear that line off, okay? Excuse me. So if I come over here now, compile, and I will run. I should have cleared the screen. Okay, I'm gonna enter my full name in here, and then age, and then college. All right, and then there's my output. Now we can also do token scans for strings, and that is, instead of using next line, you just use next, so you can avoid having to do that, right, with the line. Okay, now problem with this though is that the delimiter is space. So if you compile, you run, if I were to type in like Michael Madrigal, right, it saw Michael as my name, but then it tried to convert Madrigal to an integer. It's an input mismatch exception because that last name couldn't be an integer, so it crashed. Let me clear the screen. Right, but if I were to just input everything correctly, then this is the way it would run. Wait, I don't have to recompile, dang it. All right, so I could just type in Michael, right, age, and then, right, but as soon as I enter in like a space, it's gonna like ignore that white space, right? So technically with this though, is I could enter everything on one line. I can type in Michael, the age, and right, and it just kind of like read all that because it saw all those tokens there. It said like, I'm waiting for a string, I got it. I'm waiting for an integer, I got it. I'm waiting for another string, I got it. And it just finished it off really quick and then printed it out.
So you could do what Python does, just read a string and convert it to integer.
Yep. To me, that's actually like probably the best solution. Like if you're expecting if you're expecting data to be entered in a line, then always scan for. Excuse me, I'm sorry, I have that annoying cough. Always scan for a line and just convert that string to an integer when you're expecting an integer. If it doesn't come out to an integer, you can tell them enter an integer. Like, I couldn't convert that to a string. Re-enter this, right? But we'll talk about handling exceptions and doing that in a few weeks. Okay, but yes, like to me, that's honestly like that's the way I handle this. If I'm making a program that is actually gonna, like that I'm putting the most into, right? So like if that way, like if you can't convert, you ask for a number and enter in a string, you can tell them something like, the invalid input, or so you can catch that and tell them like doesn't make sense. All right, any questions on getting input from the user? That's interactive programs. That is, Java 1. You should have been using that a bunch. Now you can use this scanner to also scan strings and read files, but we'll talk about more about that later. All right, so that is it for chapter 2. All right, close that. Hop over to chapter 3. All right, chapter 3. What do we talk about? We talked about. Oh, there's some things that we didn't talk about from Java 1, like the enumerator types and the wrapper classes. Maybe I'll cover those too. They're pretty interesting. We'll talk more about enumerator types in chapter 7, but I'll introduce it to you now. I think I did talk about wrapper classes in Java 1. That's like the different classes for the, like if you have an int, there's a class for integer.
Yeah.
If you have, I didn't like test you on it, so you might not remember.
In the summer though, we went through.
Oh yeah, the summer class I just blazed through everything.
Yeah.
So I eliminated everything that I think is unnecessary. Yeah, you're right. If you do my class number, then I didn't cover it. All right, I'm gonna just kind of go through this really quick. So in Java, you create objects by giving it the type of data a variable is gonna hold, and then you instantiate it by using the constructor. This is the proper way to instantiate a string, but in Java, they have special syntax, excuse me, special syntax just for a string, where you don't actually have to do that. You just dang it, I'm not gonna give you an example. You can just do it with the double quotes like the way they did it somewhere, I'm sure. Come on, somebody. No, what the heck? Or maybe in here. Okay, there you go, right here. Right, well here's the object reference variable, and you just use double quotes for the string literal. Okay, you don't actually have to do the new string, the parentheses by calling the constructor like we did for our scanner right here. All right. Okay, there's a bunch of methods on the string. I wish I could just talk about them all, but it's one of those things you just have to like go and learn on your own. But let me see, what are the important ones? I'll talk about the important ones. Oh, I think trim is probably a good one. Right, so here's this interactive program that I wrote. Oh wait, this is actually gonna trim because I'm doing a token scan. Hold on, let me come over here, Control Z. Wait. Yeah. All right, hop back over here. Come to screen. Dang it, I didn't mean to do that. All right, so I'm gonna put a bunch of space in my name. All right, press enter, then enter my age, then enter college. Right, and then when it printed out this information, it kept all that white space, right? So one of the more useful methods on any programming language is the trim method, where you just eliminate the white space in the front and you eliminate the white space in the back. It's just done simply by just doing dot trim on a string, right? So this next line is returning the string object, and I'm just invoking that method on that string object, right? So you can have like stacked method calls like that. As long as what's inside of here is a string, then you can call methods that you can call on the string. Okay, and if like, let's say you wanted it to go uppercase, you can type like 2 uppercase. Okay, I don't know why you would want to do that, but just say you're entering data into a database and you don't want to have to deal with lowercase, uppercase. You just make everything uppercase, right? And I'll do the same there. So now when I compile and I run, type a bunch of space, right, bunch of space, and then I enter an age, and then a bunch of space, press enter. You can see this is now my name. Where is it? Right here, right, and this is my age, right? It basically just trimmed everything off. Pretty useful method. It's probably the most useful method right there. All right, random in math class. So Java 1, we learned how to use the random class. The math class actually has a random method on it. I always just use that whenever I need like a quick random number. Okay, so let's look at this real quick. Yeah, so I'm gonna hop back over here to, okay. Now the way what do I want to do? I'll just show you how to use the random class real quick, even though I think it's not that useful, since you can just do the same thing on the math class. All right, so if I wanted to generate a random number, I can use the random class. Go over here, call this rand new. All right, so I created a random object. Now, if I want a random number, it's pretty simple. I guess before I'm gonna save this as a different program. I'll call this one interactive program 2. All right. And the reason I'm doing that is so I can get rid of all of this nonsense. All right, so the random class, you can just say like next int, will generate a random number. So if I clear my screen, compile interactive program 2, and then run. There's a random integer. Okay, if I keep running this, right, it's giving you like a random integer over the range of what integers can be. So if I like put this like in a for loop, right, I'm going to print out 1,000 random numbers, or 10,000, right? Did I put 1,000 or I don't know. All right, so just like randomly selecting random number. I guess I did do 10,000 within the range of a random number, which I mean is pretty useless if you ask me. So if you come over here, dang it, I closed the console. I have to do all the stuff again. All right, if you come over here, you'll make this more useful. What you can do is pass a number into this method of the number of numbers that you want. So we just put 10. That's going to give you a range of 0 through 9. Okay, that means you're telling the random object you want 10 numbers. It's going to start at 0 and give you 0 through 9. So if you run this program, I have to reopen this. All right, so compile. Dang it, I compiled the wrong program. All right, so it's giving me 100 numbers, but it's keeping it between 0 and 9, right? You can modify the range by just simply like adding or subtracting, right? Just say if I wanted -5 to +5, that means technically that's 11 numbers because you're including 0, right? -5, -4, -3, -2, -1, and then the 0 is additional number, and then you have the 5 numbers from 1 through 5, right? So there's 11 numbers, but then you want 0 to start off, or you want to start off at -5. So instead of having a 0 through 10, you're going to get -5 through +5. You should anyway. Yeah, that should work. So come over here. I'm going to clear my screen. All right, and we should have a range of -5 to 5. I don't see -5. Dang it. Oh yeah, there you go, right there, -5. All right, cool. All right, but honestly, like if I'm generating a random number, I just kind of feel like if I know what the range is going to be, I think the math class is probably a more effective way to do it. So the way the math class works is it's always imported, so you don't actually need to import anything. It's the methods in the math class are static, so you don't actually have to instantiate anything, right? So I'll say like random from math. Right, and all you have to do is say math random. It's going to give you a random number for a, I forgot the range of it. It's 0 through 1, but not including 1. But it's going to be decimal. So I'm going to compile and go ahead. All right, so it's 0. It can be 0, but it can't be 1. But it's using a double, so it's any range between that 1 and 0. Now the problem arises like when you want to actually have a integer range, like just say we wanted 1 through 10. then what we have to do is you just have to like modify this variable right here, right? So if you know that you're going to get a fraction of what you want, if you wanted 1 through 10, then you could just multiply this by 10, right?
Yeah.
So multiplying by 10 will give you 0
9.
through 9, right? But in fractions. But to get rid of those fractional part, you can just cast it to an integer. So you're eliminating that fractional part. Let me move this to a different line so you can see it. Maybe wrap this in one more parenthesis to make it more confusing. All right, so that's going to give me 0 through 9, right? Now I can just add 1 to it, and then I'll get my 1 through 10, but I'm going to go ahead and just compile and run this right now so you can see it work. So it's giving me random numbers between 0 and 9, but if I wanted 1 through 10, then you simply just, here is the integer being generated, right? You just come right in here and just say +1. And now you have the 10 in there and extract that 1. All right, it's just, I mean, to me, it's just simpler to use if I'm randomly generating stuff. All right, so let's see what else we have in there. We have the formatting classes. I think they're pretty useless, I mean, for the most part. You can read about them if you want. I don't think I ever really use them. All right, so the next thing is enumeration. This is something new. We have like plenty of time. So enumerations. All right, I'm gonna go ahead and just read these slides, and then I'll give the example. I mean, it's really simple, but when we cover in chapter 7 enumerations again, it's gonna be a lot more interesting. All right, enumeration type or enumerated types. Java allows you to define an enumerated type, which is enumerated type, which can then be used to declare variables. Enumerated type declaration list, an enumerated type declaration list all possible values for a variable of that type. The values are identifiers of your own choosing. The following declaration creates the enumerated type called season. So enumeration, season, winter, spring, summer, fall. Now normally, like by coding standards, those are normally in all caps because they're considered constants. The way I like to think of enumerated types is a constant object, like you're writing in class for an object, but there's only like a certain number of objects that you can have from that one class. They just slap the enum instead of a class on top of it, so it makes it like a little more confusing maybe, but it's basically just a constant class if you ask me. Right, that's just the way I've always thought about it. So once the type is defined, the variable of that type can be declared. So here they're declaring the type season, and they're calling the variable named time. And it can be assigned a value, so time is equal to season.fall, right? So this is how you reference that constant. The values are referenced through the name of the type. Enumerated types are type safe. You cannot assign any other value to it other than those listed. That's not true. You can have a null. I don't think you can assign a null, but I think it can be null for the same reason. But is that true? Dang, I don't even know if it's true. Because technically it's an object, so it can still be null. I'll play with it and find out. All right. Ordinal values. Internally, each value of an enumerated type is stored as an integer called the ordinal value. The first value in the enumerated type has the ordinal value of 0, the second one 1, and so on. However, you cannot assign a numeric value to a enumerated type, even if it corresponds to a valid ordinal value. I think in some programming languages you can do that. Is that true? Does anybody know? You have a enumerated type, you can give it as like a 0, and it will be whatever value is in the 0 spot of an enumerated type. I don't know. I think it's possible. I could be mistaken. Enumerated types. The declaration of enumerated type is a special type of class. There you go. They said class. And each variable of that type is an object. The ordinal method returns the ordinal value of the object. The name method returns the name of the identifier corresponding to the object value. They give you an example, and that's it. All right, let me do an example. All right, so let me create a new class, a new file. Say new file, save as, I'm gonna call this one enumeration example. All right, so I'm gonna have this class called public class enumeration example, public static void main string array. All right, and I'm gonna go ahead, like, I know the book declares the enumeration inside of the same class as the main method. All right, so I'll declare it up here, but most of the time, like in a professional environment, they will actually make their own file, right? Their own, their own file for the enumeration. So I'm gonna go ahead and do that because that's what I'm gonna expect you guys to do. So I'm gonna go over here and make a new file. I'm gonna save this as, all right, let's think of enumeration. How about we'll just say like grade, or no, letter grade. How about letter grade? Okay, letter grade would be like the letter grades that you can make in a class, right, at the end of the semester. So I'm gonna call it letter grade, and I'm gonna name, or it's gonna be Java source file. Now, instead of doing public class, we're gonna do public enum. Okay, now the way to think of enum is a constant class, okay? That's the best example I can give you. Open your class, close your class, right? Like, if you look over here, follows the same pattern. The only difference between enumeration example, let me get rid of this real quick. The only difference between this class here and this enumeration here is that word, right? Enum. Same thing, right? So this class has the main method. Oops. Has the main method. But this enumeration is just gonna have whatever values that are allowed inside of a letter grade. So I'm gonna say A, B, C, D, E, F, okay? And I'm going to save that. I don't have, there's no semicolon or anything like that. At least I don't think there is. We'll see when I compile. I'll hop over here and I'm gonna just say, you know what? I want to have a letter grade over here. Since the two files are in the same folder, they can like see each other and talk to each other, right? So I can say letter grade here. Now to say like that's like where we put the data type, and the name of the variable that's going to hold it would be like my final grade. Okay. All right. And there's like, I'm declaring that this variable is going to hold enumeration letter grade. Now when it comes time to assign a value, I'm going to have to actually use the name of the enumeration letter grade and then hit dot. And I have to know all the different types of options that I have. If you're using IntelliJ, it's going to pop up to show you. But let's just say I got a B in this class, okay? And that's it, right? And then I can just say stuff like system out print line. I'll just say my grade is, and then I'm going to do a couple of things. I'm going to say that, and I'll say. Wait, actually, I didn't want to do that. Dang it. I'll say the other method you could call is ordinal. That's going to be the number that it's associated with it. You could also call name, which is going to be the name that was given to it. All right, I'm going to save that, and I'm going to compile and run. So the name of this is enumeration example. Clear the screen. Wait, I should just retype all this. Compiled, that's always a good sign. All right, and then there you go, right? So when I print out the object, just hit B. When I print out the ordinal value, it said 1. When I print out the name, it said B. If you actually wanted to see what all the values were inside of your enumeration, then what you can do, there's a method, I always forget what it is. This is why I need IntelliJ, because it could just tell me what it is, but let me think. I'm gonna use the for each loop, which is letter grade, just say like G for grade, inside of my collection, letter grade dot, I wanna say it's values, I could be mistaken. Okay, I'm gonna say system, out dot print line. and I'll say G. All right, yeah, and I'm gonna come over here and compile. Oh, compile, that's awesome, I got it right. There you go, and there's like all the options that we have in our letter grade, A, B, C, D, E, F. Okay, now, let me hop back over here and explain a couple of things. So this, I know I didn't cover this in Java 1. We are gonna talk about this in Java 2. It is a for loop, but it's like an iterative for loop, what they call the for each, meaning you have a container that holds items like an array list, some type of collection. It's basically going to say, go through this collection and copy the value from here to here. Now, the reason why I say copy is because whatever variable comes here, like if this was an actual object that we can change, if we make any changes to it, it's not going to know, the values aren't going to retain. Is that true? Maybe not. Dang it. I'm lying to you. It's for an array. If you pull the value from an array, it won't. Like, because you're using primitive data, it won't actually copy to it. Or like a for with the int 0x, you specify the index and you assign a value changes like that will actually work. Yeah. Okay. It's just a different way to write the for loop. But you can only use it whenever you're iterating a collection, right? So letter grade.values is an array or an array list. I can't remember, sorry, but it's just grabbing every value. It's basically saying like, go through this collection and every item in here, put it into the temporary variable G, or the local variable G, and that's gonna be the representation of what that object is, right? So these are all enumerated types, so I can just call like ordinal value here and get my ordinal value. Yeah, let me see. So when I come over here, I can see those ordinal values as well. Right, A0, B's 1, 2, 3, 4. Okay, so I'm gonna hop back over to this enumeration. Now the way to think about this is that this is a class that holds constant objects. These are all objects that have been instantiated, and you cannot have any object other than the A, the B, the C, the D, the E, or the F, right? These are the only objects that can be instance data. Okay, so that's the way I think about it. And when I think about it like that, it makes perfect sense to me, right? You're making enumeration to hold like a specific type of object. Now in chapter 7, you can actually come over here. You can write constructors and methods and all that stuff. It's gonna be way fun. It's gonna be cool. Something you can show your mom. She's gonna be really proud of you. And it makes these enumerations so much nicer because I can do something like, I can make like, I can come over here, slap a semicolon right here, and then say stuff like private string get, I don't know, message or something like that, right? And depending on if you get an A, a B, or C, D, you could say like, you know, you got an A, good job, or you could B, this, F, you failed, right? Stuff like that. I put an E in there. Is there such thing as an E? I just now realized that. I was just going down like, dang, sorry about that. There is no E. But anyways, you can like add stuff to this class, right? Constructors, you know, different methods. Wait, why did I do it private? That should have been public. You can do public and then like have a method that will grab all that stuff. But we'll talk about that in chapter 7.
You set the value to the enumeration based on position.
Right.
Okay.
They call that the ordinal value.
But you don't want that all the time. Sometimes you want to have.
Yeah, honestly, like every time I use enumeration, I really find no point of the ordinal value. So.
Let's say that you're reading a string from an instrument, and you could use enumeration to define whether it's an integer or a floating point or.
Oh yeah, you could do that. Yeah.
So in this case, you have to have odd numbers.
Yeah. You have a question?
Yeah, I was asking, on the website, you said use these instead of using arrays.
Oh, well, I mean, like Enumerations are used all the time, believe it or not.
Right.
But, yeah. So like where I work, we use it especially for like network calls and stuff like that, because like there's different types of failures in network calls, right? So we have our network calls defined like, I don't know, server didn't respond or bad data or
Right.
stuff like that, right? But you can also use enumerations I've seen for like statuses of servers, like if it's on, off, standby,
Yes.
right? Like, so you always want to use it for things where like a lot of times people use Boolean values for like on or off, right?
Yeah.
But you could think of this as like flags as well, where like you have more than two states,
Right.
right? But you only want it to be those states, right? So, like an example would be, I don't know.
Like system stages where you have.
Yeah.
Like
Actually, a perfect example would be like letter grades in this class, right? Like
right.
that's another example. Situations where I know I've used them at work. Oh, like different types of accounts, right? Like because I work at a bank, and there's so many. There's like at least 5 or 6 of them, right? You could have a checking account, savings account. There's like a money market account. You have a loan, like right. But there's a predefined list, and we don't want a string for that because we don't want like some bad data to come in to say like, hey, there's some weird account that we've never seen before. Like these are the only ones that we want.
Error code.
Yeah, you throw an error code, but you'd also like if you couldn't find it in that enumeration, you'd just throw an exception and say like unrecognized value, that type of thing. So you're forcing it to be this like these are the only options for this one variable. So, any other questions? No? All right, cool. All right. That's enumerations. I mean, they're actually pretty useful. I think the homework assignments in the book, like give you an example of like ice cream, like Rocky Road, chocolate, vanilla, stuff like that. One of the homework assignments. All right, so wrapper classes. Here's another, and we'll talk more about this when we talk about array list. Anyways, there's these classes, what they call wrapper classes, which pretty much just correspond to the 8 primitive data types. So you have a primitive data type byte, but you have a class called byte, right? So Java made these classes. They call them wrapper classes. If you ever wanted to treat your object, excuse me, damn it, your primitive data type like an object, you could put it into a wrapper class. The benefit to doing this is, or the reason why this is done, is some collections do not allow you to have primitive data types, right? So like an array, you can have primitive data, but an array list, you can't have primitive data, right? It was just written to where it won't allow you to have primitive data. And the reason for that is it invokes methods like compare to or equals, and it doesn't like want to go through the sake of, or like the hardship, I guess, of like determining if you're using a byte, a short int, boolean, stuff like that. I'm just going to read through these slides. Okay, the following declaration creates an integer object which represents the integer 40 as an object. So they have integer age is new integer, and they pass in 40. So it doesn't make any sense. This is another thing where, like the way the string was, is you don't actually have to instantiate an object of integer. You can just say integer with the capital I, age, and then assign it 40. And Java's smart enough to convert that to an object instead of a proto data type. An object of a wrapper class can be used in any situation where a primitive value will not suffice, like putting objects or primitive data types into certain collections. For example, some objects serve as containers of other objects. Primitive values could not be stored in such containers, but wrapper objects could be. Wrapper classes also contain static methods that help manage associated types. For example, the integer class contains methods to convert an integer stored in a string to an int value. So you can say integer.parse string, there you go, right? There's a way of reading a line and converting it to an integer. So you can do scan next line and then convert that to an int by using integer parse int. They often contain useful constants as well. For example, the integer class contains min value, max value, which hold the smallest and largest int values. So it's like that for everything, not just int values. Oops, I didn't mean to click that. So let me make a new file, save it as wrapper example. Wait, dang it, I lost my place. Oh, I'm all the way down here, what the heck? Alright, so public class, name of my class. Alright, so, I mean, some of the useful stuff that you can do, right? So what they're saying is the integer class has static methods, right? And you can look up the API and read about it, right? So like max value, right? If you want to know the maximum value of an int, you can do that. Dang, what the heck did I do? Right, but this also works for like byte. I don't know if it works for the floating point values. Short. I'll try it. Oh. All right, so like byte. So we can know what the max values of each one of these are. Come over here. Wait, dang it. All right, compile, run. So it's telling us that the max, like that's the max value of integer, that's max value of a byte, of a short. So short is 32,000, and this is the max value of a long. I don't know if it does it for double and float. I've never actually asked myself that question before, but let's find out. I'm curious to see what it says. I think it will be the same as the long, right? Because it's 64 bits, so if you don't have any decimals on that, you can represent what you can with the long. Compiled. What the heck? I don't get that. So it's exponential notation, but why is it 1.79? Yeah, I don't know. Sorry. So confused by that. I don't know what that means. I don't know how to convert that. Sorry. Anyways, that is the max value of a double. If you can figure out how to, it's saying it's 10 to the 308. It's so much bigger than, or 1.7. Yeah, I don't know. It's confusing to me. This is scientific notation with the E. All right, anyways, now I regret asking, or now I regret doing that. Okay, but there's all these cool little things that you can do. Like, so for instance, let's just say you had a string, right? And you prompted the user for like age, but you're reading it as a string, like to enter 40. You can come over here. Actually, I have an int age. Let's say age string, right? Like you can pretend like you're getting this with the next line, right? And then you could say age is equal to integer dot parse int, and then you can pass in age string. Done. All right, and you come over here, compile, run. And it was able to parse that string into an int. Right now, you can mess it up too because you still have characters in there, and then it's going to throw an exception right here. I would have to handle that exception if I didn't want it to crash. Right, and it crashed, right? Because it was saying like it could not convert. It's a number format exception. It couldn't convert that to a number, and it just stopped the program. But assuming that they entered in an actual number, right, then you can put that in there. And I think it'll auto trim for you too. Let's find out. Maybe I'm mistaken. Dang it, it didn't auto trim. I thought it did. Maybe it was just one space. Dang it. What was I thinking? I don't know what I was thinking. Maybe it comes after. Let's find out. Damn. All right, so I was mistaken about that. It doesn't auto trim. Take that back. But if you want to trim, you could just trim it right here. Right there, right? So you can ignore all that white space and it will be happy. Yeah, there you go. All right, there's a lot of useful methods in the wrapper class. It's just like literally like what I said. If for some reason, if you wanted to slap this age into, you're going to slap this age object into a, or age primitive data type into an age or object, then you can just do like integer, and I'll just say like, because age object.
You misspelled integer.
Oh, yeah, I know. I was just seeing if you're paying attention. You are. Good job. All right, so I'm putting that into an object, and now this is an object, and I can call methods on it. I don't, oh shoot, I didn't mean to do that. I don't actually know any methods off the top of my head that I can call on the integer object, but we can find out, right, with the Java API. So I'll just type like Java API integer. Click here, and then we'll just scroll down. Anything with the static is like, you see static right here? That means that you can call it through the class name. You don't actually need an object of it. Look, here's a good one, byte value. Let's try that. Okay, you can give me that's actually really interesting, right? So I'm gonna go over here and say byte value of age. And the name of the method was byte value, right?
Yeah.
All right, so,
Spelled like there.
oh dang. All right. Compile, and might not have been initialized. Dang it, that's right. I did that before. Wait, what? Oh yeah, I need to move this before that. There you go. That way it's initialized. All right. And here is the byte value. That doesn't make sense to me. 50, what the heck? I was expecting to see. Oh, I'm thinking like binary or something like that. Okay. Anyways, like, so if this was like a high number, basically converting it to a byte if it had to convert it to a byte. That's basically what it means. In my mind, I was thinking something else. Okay, so basically converted that to 78, meaning if you were trying to cast that integer into a byte, that byte would be 78. That makes more sense. I thought it was like binary. I wonder if there is a binary method on here. Convert to binary, something like that. Long value, like 2 binary or something like that. Oh yeah, there is. And I thought wait, 2 binary string. Oh, but it's a static method though. So you don't necessarily need. You can still call it on the object, but you got to pass in the value. It's not going to convert that value, right? So what that means is I can come over here and just say system out print line binary of 23. I don't know what that is, but we'll find out. All right, and I can just say integer dot to binary string. That's what it was. I don't get why it said string though. What's the significance of that? Okay, let me look at real quick. So to binary string returns a string representing the integer argument as an unsigned integer in base 2. Okay. So compile and run, and there you go. Cool. That means you can can make like your own like binary table if you wanted to using a for loop, right? So you could just come over here and just say like for int x is equal to 0 while x is less than, I don't know, we'll go up to 100 and we'll say x plus plus, and then you can just say system.out.println and say x plus, and then do integer dot to binary string, and then pass an x, save, clear, compile, run. Right? Yeah, then you just have like all your, yes, I mean, I don't know, I think that's cool, right? So 0, 0, 1's 1, 2's 10, 3's 11, 4's 100, right? So on and so on and so on. Yeah, so anyways, you can just read the Java API, and you can, there's a lot of cool things that you can do for every wrapper class. But if you wanted to, like for some reason you wanted to put your printer data type into an object, you can use the wrapper class. That's what they call auto boxing. So auto boxing is just, it converts it to an object. You don't have to know this term. I've never heard anybody refer to it as auto boxing. And that is it. It does talk about GUI stuff right here, but we'll come back to this once we do our review. All right, any questions?
Yeah, the problem you had with the floating point, could you have with the wrap float?
Oh, yeah, I guess you would, right? So, yeah, let's try it out. So you're saying if we have a double, and I'll just say like num, or actually no, float. We had a float. Again, we have num1, and then we're saying is equal to 1.5. I've never tried this before. Let's find out. All right, let me compile. Where's my cursor? I don't see it. Okay, yeah, it's the same problem. So it's seeing that as a double, and you're trying to put it into a object that represents a 32-bit. So it's incompatible. So yeah, you still have the same problem that you do. It's just, even though it's making it an object, which technically doesn't have any size, it's still keeping that number within a specific range. So you have to go over here and put that F on it. Yeah, that was a good question. Dang it, I recompiled. Yeah, so that worked. Any other questions? All right, that's all I have. Normally I give you guys quizzes, but since we're reviewing, I don't really plan to give you quizzes. Well, actually, maybe for chapter 4 I will, because chapter 4 is kind of important. That's all I have. I'll see you guys on Wednesday.